Okay, we're placing chemicals in order of increasing boiling point temperature, which means in order of increasing IMFs. In this first problem, let's assume that the molecular weights are similar enough that that's not going to be the primary distinguishing feature. If we look at these, we see water is going to have the strongest IMFs because there are two hydrogen dipole force groups, okay, meaning that we have hydrogen directly bonded to the very electronegative oxygen 2 times. So that's going to be a very strong intermolecular force, a high boiling point. HCl is polar, so it's going to have dipole forces, and it's therefore a stronger intermolecular force, higher boiling point than silicon tetrahydride, which is nonpolar and has only LDFs. In the next group of compounds, we see that we have only nonpolar molecules, some homonuclear diatomics. So these are all nonpolar. So they all only have LDFs. And therefore the only difference is going to be in terms of the number of electrons. So if we go across here, we see that the number of electrons are increasing, which explains why I placed them in this order. Increasing intermolecular forces due to an increasing number of electrons. In question C, we have a group of hydrocarbons. Hydrocarbons as a group are considered to be nonpolar. The ranking is justified by an increase in the number of electrons as we go across this group. And therefore your London dispersion forces are going to increase along with a boiling point. For D, you first note that this is a polar molecule, so it's going to have dipole-dipole forces which are absent in these two nonpolar molecules. Between the two nonpolar molecules, oxygen has more electrons and therefore has stronger LDFs.